Okay, calculate the speed of an artificial satellite in orbit around the Earth if the satellite is 1.6 times 10 to the 3 kilometers above the surface of the Earth. Oh, and here, this point here, you do not need the mass of the orbiting object to find its speed or radius. That's that's M1, right? You don't have to know the mass of that thing to figure out the speed, because the centripetal force is going to be the same regardless of what that mass is. We really need to get a model or something. Okay. So we are trying to find V. That's our question mark. Now, if I was to draw a diagram, it's saying that this satellite is this much distance away. Well, I need my orbital radius. So I need to include RE. So RT is going to be equal to RD, which is 1.6 times 10 to the 3 kilometers. This, though, needs to be in meters. So we need to multiply that by 1,000 to get our right amount of meters. And then we add that to 6.37 times 10 to the 6 meters. So our RT that we use is 6371600 meters. Now, keep in mind, whenever you do these formulas, you always are using RT in the actual big formula. Okay? So if you get a value of R, you assume that it's RT. Now also we know mass 2. We know M2 is equal to 5.97 times 10 to the 24 kilograms. So let's do it from scratch where we figure out what formula to use. FC is equal to...
I don't think your RT is right.
Oh, what is it?
I got 7.
Oh yeah, I do too. I wrote it down in a different spot. Thank you very much. 7.97 times 10 to the 6, right? Yeah. Sorry, yeah, thank you.
So you don't have to change M2 into meters?
No, this is a mass. It needs to be in kilograms. So if you're not sure, look back. Here, look, mass needs to be in kilograms. That's okay. It's good to, I said make sure you're doing your units right, so no questions about it. Okay, so I need my FC to include a V because that's what I'm looking for. So I'm going to make sure that my FC that I choose has an AC with a V. So M1 times AC is equal to G times M1 M2 over R squared. The M1s both cancel out. And I'm going to use AC as V squared over R is equal to G times M2, not M squared, over R squared. Cross multiply now. So now I have V squared times R squared equals G times M2 times R. These two R's cancel out. I want to isolate for V, so I'm going to divide this side by R, and then I square root it to solve for V. So the formula that I use is V is equal to the square root of G times M2 divided by R. So if you take the time to do rearranging your formula, you only have to do one calculation really, which is kind of nice. So then we put this in. V is equal to the square root 6.67 times 10 to the negative 11. I'm just gonna erase it. You can look, I just did that in the notes too, so, oh, yeah, that's special. Times by my mass of the Earth, because that's M2, because that's the mass that's actually producing that gravitational field. So our answer is in meters per second. So 7,068, etc. meters per second. So to sig digs, that's 7.07 times 10 to the power of 3 meters per second.